Hi, good morning. My name is Mayra.
Hi, good morning. My name is Esmeralda.
Good morning, my name is Erica.
Good morning, my name is Eduardo.
I'm Gabby.
Today we'll be going over Newton's first law of motion, the law of inertia, aka. And today we'll be giving you a demonstration right here. Okay. So what is inertia?
Today we will be going over Newton's first law of motion, also known as the law of inertia. This law states that objects in motion will stay in motion and objects at rest will stay at rest, unless acted upon by an external force. For this demonstration, I have two eggs that look identical from the outside. One is raw and the other is hard-boiled. I will begin by gently spinning them and gently stopping them with my finger. Observe what happens to each egg after I let go. Pay close attention to whether the eggs remain stopped or begin moving again.
So when we spin both eggs, the boiled egg will completely come to a stop, mainly because external force is applied, while the liquid will continue to spin. This demonstrates Newton's first law. How this applies to the real world. In the real world, when we hit a hockey puck across the ice, it will continue to move. It will continue to move because it is not being acted upon by an external force, as the ice provides very little friction. Another example, a soccer ball. A soccer ball will stay there. It will not move unless it's being kicked by someone else. Being kicked by someone else is the external force. Another example in ultrasound will be patient positioning. When a patient is lying down on the exam table, they remain at rest. They only change position when the sonographer asks them to roll, sit, or move. The sonographer's instructions or gentle assistance provide the external force that changes the patient's motion.
During an ultrasound exam, the transducer naturally remains still until the sonographer applies force. And to obtain a clear image, the sonographer initially moves and adjusts the transducer. If the probe moves unintentionally, the image quality decreases. This demonstrates Newton's first law because the probe stays at rest until force is acted upon it.
The connection to ultrasound is the core of hemodynamics when blood flows through a straight vessel and suddenly hits a sharp bend. The fluid blood wants to keep moving in a straight line due to inertia, exactly like the egg fluid.
Centripetal force is a center-seeking force required to overcome the inertia of a straight line. This is why the raw egg will continue to spin, as the curved wall inside of the eggshell acts as a boundary.
Newton's first law tells us that the objects resist changes in motion. Objects at rest stay at rest, and objects in motion stay in motion unless an outside force acts on them. We demonstrated this using the egg experiment and connected the law to diagnostic medical sonography through patient positioning and proper transducer handling. Understanding this law helps us understand both everyday motion and the importance of controlled movement during ultrasound examinations.